Hey everyone, Mr. Rubo here. Today we're going to talk about systems with absolute value equations involved. Um, so we're going to have it where there's one absolute value equation and one linear equation. So there's going to be three cases we're going to deal with. Technically there's four, but you won't see the fourth one very often. So the first one is where if we have our absolute value and our linear function and they intersect at two spots. This would have two solutions. Just like before, the intersection are those solutions, so those two coordinate points. Another one, as you could probably guess, is if there is one solution. So you can see here that this line hits one of the sides, but because of the slope of the two, either they're the same slope or possibly this one's even steeper, um, they won't ever touch. So we have one solution. And once again, it's that intersection point. The last one that we really see in this class really is no solution, which would be where your line just completely misses it, so you get no solution. The last one that really doesn't happen very often at all, really won't happen in this class either, is if your line ends up being on one of your sides here, so just right on the top of it, this would be infinitely many solutions, but this is one doesn't happen very often. All right. So if you're graphing them, you can easily figure out your answers from looking at your graph. All right. Now, what we're really going to talk about today is how to solve them algebraically. So if you have, we'll do it in red, your two equations, y equals x plus 2 and y equals the absolute value of x minus 3, unlike just a regular linear system, we can't use elimination, okay? Because these absolute values kind of trap this x minus 3 in here, and we just can't eliminate stuff. So, nice thing is, though, we have another method, which is substitution. So we can always do substitution. And this is y equals, so we can take this, substitute it right in for y in the other equation. And then guess what? We know how to solve this, right? We've dealt with these multiple times in previous classes. So when you see the absolute value equal to something, well, you know that it's going to equal the positive version. So x minus 3 equals x plus 2, and x minus 3 is also equal to the negative version. Okay? So let's go ahead and solve this first one on the left. Oops. All right. So we subtract the x's. Well, when you subtract x from both sides, it cancels on both sides, and you're left with negative 3 equals 2. This hopefully doesn't make sense to you, which means there is no solution from this equation. Okay? So that's telling us that it's not two solutions, right? It has completely missed it. So yeah, now we look at this one in red, and maybe this one will have a solution. So x minus 3 stays the same, negative x minus 2, add x to that side, add 3 over here, and then divide by 2, and you get x equals 1/2. Okay, so when we look at this, we have our x value, we need to figure out the y value, and nice thing is both things are already set up where they're y equals, so we can go ahead and use either one to solve for y, and I would usually just do the linear one because it's going to be easier to solve. 1/2 plus 2 is 5/2. So our coordinate point is 1/2, comma 5/2. Okay, and I would highly, highly, highly suggest substituting these in back to the original and just making sure you get the correct answer. Okay, 1/2 minus 3. Well, that would be negative 5/2, but it's in the absolute value, so it is positive 5/2. So it does work here. So this right here is your correct answer. And as you can see, there was only one solution because the other side, they would never have intersected because they were parallel. Okay. So yeah, have a good day, and I'll see you soon.